Hello and welcome. This training module was developed by New York Integrated Food Safety Center of Excellence and covers the introduction to HACCP principles for food service and retail establishment. This training module will consist of 5 parts. After a brief introduction to origins and basic concepts of HACCP, we will go through prerequisite programs and other food safety systems like good retail practices and good manufacturing practices that are needed as the solid foundation in any food establishment before an effective HACCP is built on top of it. Once we are familiar with the prerequisite programs, we will go into more detail on individual HACCP principles and see how this food safety management system functions overall. We will go through some specific examples and formats of how HACCP plans looks like and finish with a brief overview of major concepts and lessons learned. We start by explaining what is HACCP. HACCP is an acronym that stands for Hazard Analysis Critical Control Point, and it is a preventive, systematic approach to food safety that focuses on the identification, evaluation, and control of food safety hazards. It is a food safety management system that systematically looks at all potential hazards that are present, critically evaluates each hazard to determine how likely it is that a hazard will cause harm and how severe this harm would be, which we call risk, and after this, it establishes the necessary controls for each hazard that represents an unacceptable food safety risk to human health. So in step 1, you perform the hazard analysis to identify any potential hazards associated with the food and determine if they are reasonably likely to occur, meaning it represents an unacceptable risk. And in step 2, for all hazards you identified as representing an unacceptable risk, you establish the critical control points, or CCPs, that will eliminate them or lower the risk to acceptable level. Food safety professionals like to say there is no zero risk, but risk can always be lowered and controlled at acceptable level. Once you go through this process and you establish appropriate controls, you would periodically repeat this process to see are there any new hazards, any old hazards that now have a higher risk, and finally also evaluate the CCPs you have in place. Do these still control the risk or do they need some adjustment? A little bit of history. Where did HACCP originate? It was developed for NASA's space program in the 60s, and it was designed to adopt a more proactive and preventive approach instead of reactive. We said that there is no zero risk, but when NASA decided to send people into outer space, they had to establish a system that would get this risk as close to zero as possible, because you don't want to have any foodborne illnesses in zero gravity. So they developed the system we just described. You think about what can go wrong and establish procedures that one by one control everything that can go wrong. So a good hazard program should be proactive and preventive, addressing a hazard before it causes harm. It should be science-based. Scientific information is what helps us decide what are the hazards we need to control, as well as how we will control them. As effective as HACCP as a food safety management system is, it will never be effective if it's not built on good solid foundation represented by good prerequisite programs, good retail practices, or good manufacturing practices. Making sure food is cooked to appropriate temperature will not work in assuring food safety if the food is cooked and prepared in rat-infested establishment. Before we can cook safe food and serve safe food, we have to assure we are cooking it and serving it in a pest-free environment. And there are a number of other prerequisites or common sense points we will briefly go through in the slides to come. Before we move on, another illustration of how to build a food safety management system pyramid. And you can see that it goes even lower than prerequisite programs. You need people that want to make safe food. You need people that care about work they do to make sure food is safe. And we call this food safety culture. Doing the right thing even when no one is looking. Keeping the controls in place even if no one is getting sick. And knowing that no one is getting sick because of the work you do. And a big part of this food safety culture is commitment of the higher management to food safety. These systems require time and finance commitments, and management has to be on board securing these resources. Next, above prerequisites are written procedures, standard operating procedures, and sanitation standard operating procedures to make sure procedures are done correctly every time so the outcomes are effective and consistent every time. One thing to remember and worth conveying to any establishment that should implement HACCP or any other food safety management system is that delivering safe food is not just protecting the consumer, but also the business. Outbreaks and illnesses can be expensive, and reputation as establishment that caused it can last a long time. Many establishments never recover from it and have to shut down because of it. Now, HACCP is a well-known in food processing space and is even a regulatory requirement in a number of cases, including in countries outside of US. We have USDA's HACCP that meat and poultry processing facilities have to follow to deliver a safe product. We have seafood HACCP, juice HACCP. We also have food safety plan that as part of preventive controls for human food regulation, FDA requires from all food processing facilities that are shipping across state lines. Although this one is a more recent food safety management system and upgraded in many aspects, it is still built on the same hazard analysis and HACCP principles. When it comes to food services and retail, HACCP is to most part established on voluntary basis, and only in rare occasions, depending on the state and local regulation, is it required. FDA published a document on how food service and retail establishments can implement a voluntary HACCP to manage food safety. And with it, they also published a document for regulators to apply HACCP principles in their inspection and evaluate any food safety management system from a HACCP perspective. So, we said the HACCP implementation is to most part voluntary for food service and retail establishment and dependent on state and local regulatory bodies that are regulating these establishments. But there are some special circumstances when these state and local regulatory bodies make implementation of HACCP system mandatory, and some of the common examples are, for example, when requesting a variance, so a written permission to change or skip one or more requirements spelled out in the state or local food safety rules. Or another example is when a specialized food process is used. For example, New York City Department of Health and Mental Hygiene says you have to have a HACCP plan when you are packing food in reduced oxygen packaging. For example, sous vide is becoming popular, or standard vacuum packing that always needs special attention due to CBOT. They also say you need HACCP plan when you are curing meat, poultry, fish, or other aquatic animals, when you are drying meat or poultry, and when you are fermenting any foods that require time temperature control for safety, for example, making different sausages. Or you need it anytime you are processing foods in a way that is not specified in the health code, and you need this process to be approved. Another reason for making HACCP mandatory for some establishments is when state or local authority sees this as necessary step for assuring safety of the food that the establishment is making. For example, repeated or continued violations of the health code. For example, if establishment caused a foodborne illness or an outbreak, having them build a HACCP plan can help them establish back control over the food safety hazards before they open again for business. And with this, we finished our brief introduction, and we move on to prerequisite programs that we said are an important base on which HACCP is built. For establishments where food is produced, processed, prepared, or in other way handled, prerequisite programs are to different degrees covered by different practices. For example, for food processing facilities, we refer to them as good manufacturing practices, and for retail and food service establishments, we refer to them as good retail practices. And all of them have a lot of overlap because all of them are covering the basics of food safety. And when an establishment is inspected, an inspector would always make sure these practices are in place and functional before evaluating other aspects of the establishment. We can call these practices common sense, and if we quickly go through some of these we have listed here as the most important and common ones. For example, it makes sense that establishment will not be able to make safe food if people that are preparing, arranging, and serving food are ill with foodborne or other illnesses. For example, if they have gastrointestinal problems because of norovirus or salmonella infection. Same goes with personal hygiene. Even healthy individuals can carry pathogens and transfer pathogens from environment to food if they are not washing their hands, if they wear dirty clothes, and similar. Next are plant and grounds. It will be very difficult to make safe food if the establishment is placed in the middle of a swamp and the place is constantly flooded. Or if food contact and non-food contact surfaces cannot be properly cleaned and there are pests running all over the place. If restrooms and hand washing sinks are not clean or even available, or if equipment used to make food does not have a sanitary design that allows equipment to be effectively cleaned, or if required equipment is not available at all. For example, a dishwasher or a 3-compartment sink to wash the dishes, or refrigerator to keep TCS foods cold. We mentioned equipment. One is to have the right equipment, and the other is to be willing or know how to use it appropriately and effectively, and there are other processes that need to be in place. For example, knowing how to prevent cross-contamination. And this brings us to overarching point of good manufacturing or retail practices. You need trained and qualified people doing each task. If employees do not know what they are doing, it will be hard to make safe food even if HACCP is supposedly in place. All it takes is one person and the entire system can collapse. And with this, we finish a quick overview of prerequisite programs that you are probably already familiar with. And we move on to the main topic of how HACCP is built on top of this base of prerequisite programs. HACCP is a systematic process of identification, evaluation, and control of food safety hazards. There are 7 basic principles that help keep it systematic and organized. Principle 1, conduct a hazard analysis, followed by determine the critical control points or CCPs, establish critical limits, establish monitoring procedures, establish corrective actions, establish verification procedures, and finally, establish record keeping and documentation procedures. Before we go through these principles one by one to see how they build on each other to form an effective food safety management system, we will look into HACCP preliminary steps that are recommended and useful before going through the process of building the actual plan. So what are these preliminary steps? Number 1, you want to assemble a HACCP team. And this team should be as diverse as possible to capture all activities that are occurring in the establishment. For example, person that is ordering the ingredients, person that is cooking the meals, person that is serving the meals, person that is cleaning the establishment, equipment, and utensils, person that is serving the food, and highly important, person that is managing the establishment and managing the business. Having all of them be part of the process means they are more likely to follow the system and know how to follow the system, including middle and higher management whose commitment to the system is essential. If they don't provide time and resources to establish and maintain the system will not remain active or effective for long. Next, a good description of the food the establishment is making. The recipes, what ingredients are used, or where are these ingredients coming from? Where is the food served? Is it distributed somewhere? For example, e-commerce is on the rise, and more food is not consumed at the establishment anymore. So clear understanding and description of who and how the food is distributed to the consumer is needed. The consumer itself should be well defined. Who and how will the food be eaten? If the restaurant is next to the hospital or retirement home, The customer will represent a different risk profile, and the HACCP program should adapt. We mentioned recipe. Before we start building HACCP, we should have all the steps that convert the ingredients to final menu items well defined and characterized, and flow diagrams that visually describe all important steps and how these are connected can make the entire process much easier. Of course, the flow diagram will only help in final HACCP work if the flow diagram is showing what is actually being done. So verifying all recipes and flow diagrams before you start is always a good idea. Now, an inspector or environmental health officer might ask the management of the establishment to go through some or all of these steps by themselves before they come in and assist them with building the final HACCP. This way, everyone that will be involved in the process of building a HACCP program are already familiar with the information, committed, and engaged before the process starts. Now we can truly start building a HACCP program using those 7 principles. Principle 1 is about looking at all the ingredients that go into a specific menu item and think about what hazards are coming in with them. For example, we are bringing in raw chicken. This means we are bringing in potential salmonella and campylobacter that would need to be eliminated or controlled before the final dish is served to the customer. During hazard analysis, we are also going through a specific recipe or flow diagram and think about what other hazards can be introduced in the establishment, or what hazards can be enhanced due to growth, and what steps are the ones that can reduce the hazards. These last ones are the ones we will select and most likely leverage in our HACCP plan to make sure each hazard is controlled. In food service and retail establishment, biological hazards are the ones the HACCP plan will most likely focus on because these are the hardest to control and have the potential to cause most harm. However, although most other hazards like physical and chemical hazards are expected to be controlled by all of the prerequisite programs, the same HACCP principles can be used to control these hazards as well, if the decision is made that these represent high enough of a risk to the customer. And this is what the results of hazard analysis is. It is a list of all the hazards for each of the menu item that we determined to be high enough of a risk to the customer that need to be actively controlled. How do we control them? Well, with critical control points or CCPs. For each hazard that was identified to be high enough of a risk, there should be at least one CCP in the process that controls this risk. This is a flow diagram that can be used to determine is a specific step in the process of making a dish a CCP or not a CCP. You start by question 1, is there a way in the entire process to control this hazard? If no, it means a safe dish cannot be made. Something needs to change in the process to be able to make it safe. Either not introduce the hazard or have a way of controlling it. If yes, you go through each step in making the menu item and you ask the question 2. Is this the step that will control the hazard? If yes, then this is your CCP. And if no, you ask yourself question 3. Will this step make it worse? If it will not make it worse, this is not a CCP and you don't have to control it. If it will make it worse, and in question 4 you say there is no other step to control it, then you have to control it at this step and you do make this step a CCP. If you say yes, there is a subsequent step that will control it, this is not your CCP, but the subsequent step you identified as effective is your CCP. Now, as you go through Principle 2 and you identify the CCPs that are required, you also work on the next principle, Principle 3, which is establishing the critical limits for these CCPs. If cooking is a CCP, we have to know the temperature or temperature and time we want to achieve every time we cook a specific dish. And this is where the science comes in. We have to use critical limits that are supported by science and validated by science, which all limits prescribed by government agencies are. For example, cooking poultry to 165 or ground beef to 60, these are both validated and supported by science. These are the typical operational steps conducted at a food service or retail establishment. The steps listed in the middle are the ones that will most often be established as CCPs, but CCPs can be established at any of these steps. We will briefly go through these steps, point out some of the specifics, and offer some separation between hazards controlled by prerequisite programs and CCPs established as part of HACCP. Remember, prerequisite programs like good retail practices or good manufacturing practices are designed to control most of the hazards, but they are not making sure they are controlling every single one every single time. While HACCP and CCPs are implemented to control only the most important hazards, but they are designed to make sure each is controlled every single time. There are three general types of dishes and processes that are performed in food service and retail establishments that will most often determine how CCPs are established. Process 1, food preparation with no cooking step. You receive the ingredients, store it, prepare without cooking, and after cold holding, serve it. Process 2, preparation for same-day service. Receive, store, prepare with cooking, and after it is hot held, it is served. And finally, process 3, more complex food preparation, where after cooking, the food is cooled and reheated for hot hold and serving at a later time. The temperature profile, potential for microbial growth, activity, survival, and toxin production, as well as risk, is different for each. They cross the temperature danger zone either never, once, or 3 times during the process, which makes a big difference in the risk profile. So we start with receiving of ingredients and food. Receiving the food at proper temperatures and getting perishable food into cold storage quickly. Obtaining food, ingredients, and packaging material from approved source, so suppliers who are regulated and inspected by appropriate regulatory authority. All these are usually covered by prerequisite programs. But for some, like seafood, this step could be made a CCP. For example, to make sure the hazard like scombroid poisoning with histamine is controlled. Similar principles to establish a CCP or have it be covered by prerequisite programs could be followed for cold storage as well. If we use seafood example again, CCP could be established for frozen storage of certain seafood to eliminate the hazard of specific parasites. Other hazards, for example, coming from cross-contamination, could be covered by prerequisite programs like separating raw from ready-to-eat foods in the cold room. In the preparation phase, there is the greatest variety of activities that can occur, most of which are controlled by prerequisite programs, but some can be so critical, for example, to limit growth of pathogens that a CCP is established. For example, having strict control of temperature and time during thawing of foods to prevent growth of pathogens, or having strict control of cleaning and sanitizing of specific equipment to prevent contamination of ready-to-eat foods with pathogens from the environment, for example, with Listeria monocytogenes. For example, we could have strict cleaning procedures for deli meat slicer, where concentration of cleaning solutions and sanitizers are measured and recorded, exposure times are measured and recorded. There is even a possibility of verifying cleaning success with devices like ATP bioluminometer that large food processors are already routinely using. Next is cooking that applies to process 2 and process 3. Cooking foods is the most effective operational step for reducing or eliminating the most common pathogens and should always be considered as CCP, especially when cooking foods of animal origin. Cooking as CCP is determined based on product and hazard combination. For example, poultry would be cooked to minimum 165, while a beef steak to minimum 145 to control pathogens. Next is cooling and reheating that applies to process 3. One of the most labor-intensive operational steps is rapidly cooling foods to control bacterial growth, which is why it is often performed incorrectly. Improper cooling of potentially hazardous foods has been consistently identified as one of the factors contributing to foodborne illnesses. Foods that have been cooked and held at inappropriate temperature provide an excellent environment for the growth of spore-forming bacteria. Growth and toxin formation that occur during improper cooling can potentially represent a risk that cannot be eliminated with a subsequent reheating. Proper reheating provides, similarly as cooking, important control of vegetative pathogens and some of their toxins, but will not eliminate spore formers and some of the other toxins. Having this step via CCP is just as reasonable as having cook step via CCP. But consideration needs to be made when this step is implemented as CCP. For example, even a proper reheating of foods will not control some of the hazards if the food was not properly cooled or stored before the reheating step. Holding, either hot holding or cold holding, is the last step in the process that a person might typically consider as critical control point versus prerequisite program for control of pathogens. Time or temperature or both can be used as parameters of CCP during holding of food. There are a number of different versions of controls that could be established as CCP with careful consideration of controls and corrective actions that are available. This step is also one of the steps that could expose the food to additional hazards like recontamination, especially if holding is part of self-serve buffet. Prevention of contamination by customers and personnel at this step is usually controlled through some type of prerequisite programs. And so are usually setup, assembly, and packaging that are often used by some establishments like caterers and when food is delivered to homes. These steps are usually covered by prerequisite programs. However, a person could also establish a CCP in this step, especially if this step is combined with a hot or cold holding of prepared foods during, for example, transport. Serving and selling the finished dish is the final operational step before the food reaches the customer, and a number of considerations that are part of prerequisite programs are usually made here. For example, procedures for proper hand washing and glove use, exclusion and restriction of employees, and again, specific procedures if this step involves customer self-service. We looked at the principles 2 and 3 with emphasis on some of the considerations and differences between CCPs and prerequisite programs. Now with principle 4, we start the part that truly separates CCPs from prerequisite programs. So it starts with establishing monitoring procedures. While prerequisite programs are established, rarely are these monitored enough to make sure these are followed every single time they are performed. We hope and trust employees that they will properly wash their hands when they are using restrooms. Rarely is this process monitored every time or all of the time. With CCP, we are monitoring all the time and every time to make sure we are controlling the hazard every single time. And if we are not controlling the hazard, we want to know this immediately so we can do something about it, also known as doing a corrective action. When we know what our CCP is, we should know what the critical limits are to control the hazards, so we should also know what we will monitor. Are we monitoring temperature? Are we monitoring time, or both, or something else? Next, how we will monitor. What device will we use? If it is a thermometer, what type of thermometer, and similar. Next is when and how often will we monitor. We have to make sure that the monitoring interval will be reliable enough to ensure hazards are being controlled. Next, who will be responsible for monitoring? Is it going to be manager, cook, assistant cook, or any other reliable employee? There can be also other considerations. For example, equipment used for monitoring of specific CCPs have to be accurate and routinely checked and calibrated to ensure that what we are measuring is correct, critical limits are met, and hazards are controlled. Next is Principle 5, establish corrective actions, which we need every time our monitoring under Principle 4 indicates that we did not reach the critical limits, which means that the hazard was not controlled. You have to know what you will do when this deviation happens, and you have to know it before it happens. So each CCP we establish needs a corresponding corrective action for when the limits are not met. A corrective action may be simply continuing to heat food to the required temperature or diverting it to another dish. For example, a burger that did not reach the temperature during cook could be used to make a beef chili or something similar that will go through additional cooking at the higher temperature. It is very important that employees understand the corrective actions and to make corrective actions as easy to implement as possible, so these are effectively implemented whenever they are needed. There should be no decision process involved in corrective action. No debate about should it be done or not. If there is deviation, the corrective action must be performed. When it is done, it should be also recorded. And when deviation is recorded, someone has to verify that a corresponding corrective action was taken and it was effective. Which brings us to Principle 6, establishing verification procedures. Verification is simply making sure that what needs to be done is done. It's done correctly and according to the original plan spelled out in the HACCP program. For example, a cook roasts a chicken. Did they measure the temperature of the chicken during roasting? Did they reach critical temperature of the chicken? If they did not, did they perform the corrective action? In HACCP, these questions never remain unanswered. We always make sure the temperature is measured, that the critical temperature is reached, and corrective actions performed if critical limits were not met. Because we want to control the hazard every single time a cook roasts a chicken, and we want to have a record of it that we did it and we did it right. Now, who will perform the verification? Well, someone else than the cook. But this person should be defined in the HACCP plan we build, so we always have this step covered and person assigned to do it. A cook can forget to measure the final temperature, but two people less likely. And if cook did forget to measure the temperature, there should be a corrective action for this too. What do we do if temperature was not measured? When and how often is verification performed, it depends on activity. Visual verification of cleaning of deli slicer might make sense to be performed immediately after it is cleaned or right before it is used. Verifying cooking logs might make sense to do daily or more often, for example, before the food is served to the customer, because cooking is controlling a lot of risk and number of different hazards. Receiving logs may be acceptable to do weekly, or weekly visual verification the temperature of foods during cooking is actually being measured. Usually, none of the written records should take more than 1 week to be verified. Now, you can imagine that verification or records will only be possible if activities are actually recorded. This is why record keeping is so important and represents the last principle of HACCP. Records are also something that an inspector or environmental health officer can use to go back in time and see how HACCP plan is followed, do the tasks and timeline make sense, and is their entire system effective in controlling all of the hazards. All activities related to HACCP should be recorded and verified. There are at least 5 types of records that should be part of HACCP program. First one is the HACCP plan itself, that shows what is establishment making, what are the associated hazards, and how is establishment controlling these hazards. Second one, records of monitoring CCPs. So what were those cook or cooling temperatures and times when menu items were prepared? Number 3, records of corrective actions. So whenever we see a deviation in CCP monitoring records, there should be a corresponding record of corrective action. Number 4, verification records. So all records should be verified and all verifications should be recorded to make sure HACCP is functional and hazards are controlled. Number 5, calibration records. So any devices we rely on to tell us are we reaching the critical limits or not should show us the true values. Everyone is encouraged to have records of activities related to prerequisite programs to make sure the strong base HACCP was built on is maintained strong. If nothing else, records of training people receive need to be kept, so they can always show employees are aware of food safety issues, know proper hygienic practices, and know how to perform individual tasks inside and outside of HACCP. These records also help to know when is the time to repeat the training and refresh their memory. Some other specific records could also be receiving logs, food storage logs, cooking logs, reheating logs, cooling logs, pH logs, refrigerator temperature logs, and similar. HACCP team is responsible for designing the system, but effective day-to-day implementation, including record keeping and verifications, involves every employee. Review and update of HACCP plan. HACCP plan, like any other food safety management system, should be a living thing that is constantly evolving and changing because conditions are never constant. Employees change, ingredients change, menus and how we make food change, and all these are changing the hazards and risk profile of the foods. So the HACCP plan has to change with it to keep controlling all of the hazards that are there. So anytime there is a change, the HACCP plan should be reevaluated to see if hazards are still under control. But even if nothing changes, HACCP should be periodically evaluated to check if anything changed that we didn't notice. This HACCP review is sometimes referred to as validation, although validation is a specific term and is a process of determining if a process is truly giving us the results we want. For example, is HACCP really controlling all of the hazards we are using it to control? For example, is cooking chicken to 165 truly controlling salmonella as the risk? Which can be difficult for a food service or retail establishment to determine. This is why we rely on government and academic institutions that recommend heating, cooling, reheating, and freezing controls, for example, minimum temperature to cook a chicken, to base these recommendations on validated data. The duty of the establishment is to apply those controls by reaching the critical limits and by verifying that these limits were reached. And after that, the validation academic and government institutions did assure that hazard is truly controlled. And with this, we finish the introduction to all 7 HACCP principles. Now let's see more practically how a person would apply these principles in a food service or retail environment. First, an example of a table that could be used during process of hazard analysis. You would use this for menu item or group of similar menu items. So we have here an example of ham and eggs or egg scramble. You list all of the steps in column 1, starting with ingredients that are received. We have some examples here, for example, receiving eggs, receiving pan oil. In column 2 and 3, the HACCP team would think about and identify any hazards. So we know salmonella in eggs is a hazard. We can also consider egg as an allergen. Next, we have pan oil, which is, for example, soy oil, and this would mean that this is maybe another allergen we might consider. In column 4, the team thinks about CCPs and how to control the hazard and also defines in the last column, is this the step where CCP is applied? If not, somewhere further down the list, there has to be a CCP that controls this hazard. And if we do go further down the list, we will find the cook step where this hazard is spelled out again. And in the last column, we call this step a CCP, where Salmonella is controlled. These were just a few examples. The team would list all of the steps involved in making the menu item. And this is where having a flow diagram of each is very helpful, since the team only needs to copy and paste all steps that are in the flow diagram into this table and then consider each step for hazards and CCPs. Next, we will look into 4 options of how the main parts of HACCP plan can be formatted, since there is no strict rules about the format. The format should be used to fit the needs of the individual establishment and the people working there. This first one is grouping everything by steps that represents CCPs in different processes. For example, this is a group representing cooking. It lists all of the foods that are cooked and defines the critical temperatures and times that need to be reached. For example, eggs you need to cook to 145 or 155 for 15 seconds, whole roast to 130 for 112 minutes, poultry to 165 for 15 seconds, and similar. If we continue with this document, what follows is defining how this step will be monitored in all situations. For example, it says we will use a probe thermometer at the end of cook step. What will be a corrective action when we don't reach the critical limits? Do additional cooking and recheck the temperature. Verification. Here the team would decide who, when, and how often and how verification will be done. Maybe by visual observation of the person doing the temperature measurements. After that, they list all of the equipment that is needed. And finally, it lists all of the menu items that have cook step SCCP in them. For example, fried chicken, macaroni and cheese, and other. The HACCP team would make a similar table for other CCPs, for example, cooling, reheating, and similar. Example 2 is HACCP plan for individual menu item. So you would have as many of these tables as you have menu items. This one is specifically for chicken noodle soup. It first lists all of the steps and defines which ones are CCPs. Cooked chicken is a CCP type 1, followed by preparing a soup, which is not a CCP, followed by cooked soup, which is again CCP type 1. After that, hot hold, which is type 2 CCP, cool as type 3 CCP, reheat as type 4, and so on. After, it lists all these 4 types of CCPs and defines them. What is the critical limit? What is the monitoring procedure? What is the corrective actions for each? Here we have a CCP 1 and CCP 2. And if we continue down, CCP 3 and CCP 4. After, it defines the verification steps and finally the equipment that is needed. Third example is again focusing on the individual menu item, but this one goes in even more into detail. It follows a recipe for each menu item. Column 1, list of ingredients. Column 2, list of procedures these ingredients go through. So in columns that follow, they define, is it a CCP or not? If it is, they define the monitoring, the corrective actions, and verification procedures. If we go further down the list, the ingredients are not listed anymore because they went through initial preparation steps. The procedures that are left are the ones that combine them into the final menu item. And these are again characterized as CCP or not a CCP, and everything that needs to be defined if these are CCP. Like bake the final pie. This is another CCP. Procedures for hot holding, cooling, reheating follow them, and all of them are listed and defined. The final example separates the menu items by 3 food preparation processes we talked about. Process 1 with no cook step, process 2 with cook step and same-day service, and third process is the complex process where food is cooked, cooled, reheated, hot held, and served. So in this final HACCP plan, we have them grouped by these three processes. This one is for process 1 with no cook step. It lists all of the menu items that would be in this process group. So tuna and chicken salad, cold meat sandwiches, and cut melons. It defines the CCPs, critical limits, and equipment in column 1. It defines monitoring in column 2 and corrective actions in column 3. And then finally, verification in the last column. And after, there is a second table that describes everything in the same fashion for process 2 and after for the process 3, the complex process. It says, follow everything that is defined in process 1 for cold storage, follow everything in process 2 for cooking and hot holding, and then additionally defines only parts that are new and unique to this process 3. And this would be cooling and reheating steps as CCPs. With this, we covered all of the material. To finish, let's do a quick overview of what we looked into during this session. We looked at the most important prerequisite programs, including good retail practices and good manufacturing practices that represents the necessary base to build an effective HACCP on top. We looked at the preliminary steps in building a HACCP program that can help us in the process. 2 steps worth mentioning again. Number 1, a good flowchart for all menu items goes a long way during the process of building HACCP plan. And number 2, a good HACCP team goes again a long way to build and maintain an effective HACCP program. And finally, we went through the 7 principles of HACCP that build and make up the final HACCP program. And we also looked at 4 specific examples of documents to get a sense of how a HACCP plan can be formatted in different ways, fitting the needs of an individual establishment and people that work there. Finally, to put it all together, HACCP, when combined with good basic sanitation and solid employee training program and other prerequisite programs, can provide retail and food service industry and its regulators a complete food safety management system that can provide safe and quality food to the consumer. Thank you.